Rules for significant figures. All non-zero digits are significant. So for example, if we have a number like 532.7, every one of these are significant, so we'd say we have 4 significant digits. If we had a number like 0.321, all of them are non-zero numbers, so they're all significant. We got 3 significant figures there. Rule number 2 is that final zeros after a decimal place, final zeros after a decimal are significant. Okay, let's look at this 52.0. Notice that this is a final zero. It is after a decimal point. So it is significant. We have 1, 2, 3 significant figures here. Let's take a look at 5.00000. Notice that these are final zeros after your decimal place. We have 1, 2, 3, 4, 5, 6. We got 6 significant figures there. Rule number 3. Zeros between 2 significant digits are significant. So if we have 3107, it's between 2 significant digits, so they're all significant. So we got 1, 2, 3, 4 significant figures there. This 0 is between 2 significant digits, so we got 1, 2, 3, 4 here. Rule 4. Zeros used only as placeholders are not significant. Now this may seem a little bit difficult to understand, but if I put my numbers in scientific notation, it does make a lot more sense. If I give you this measurement here, these are only considered placeholders. Understand that, let's say we want to measure 32 milligrams. Well, 32 milligrams is the same thing as 3.2 centigrams or 0.32 decigrams or 0.032 grams or 0.0032 decagrams or 0.00032 hectograms or 0.0000 kilograms. This is what we mean by placeholders. These zeros are just holding that decimal in place for us. Okay, another example is if we say 5, 1, 2, 3, 4, 5, 6 miles away. Understand that if we're talking about a huge distance like that, we're really not going to be extremely precise. If we say that something is 5 million miles away, we probably are not giving the exact distance. The real distance could be 5,375,972.5, but we just wouldn't talk about that in normal terms, in just normal conversation. So often when we're dealing with numbers, we would just say 5 times 10 to the 6th. What I'm trying to get at here is that these are merely placeholders. They're just holding our decimal in place. When you put numbers into scientific notation, that helps you to see which zeros are your placeholders and which ones are not. In scientific notation, this number would be 3.2 times 10 to the negative 1, 2, 3, 4, 5 times 10 to the negative 5. Now, I hope that this explains what the meaning of a placeholder is. These zeros here are just keeping my decimal in this place, as are these. So these zeros are not considered significant. These zeros are not considered significant. They're merely placeholders. So this number, whether it's written like this, this, only has 2 significant figures. Let's take a look at some examples. If I have the number 3,000, I only have 1 significant figure. That's my 3. Look what happens though if I have a 3,000 and I put a decimal there. What this is telling the reader is that I have a piece of equipment, maybe a scale, and that it measures accurately, or precisely, all the way down to my ones digit. So in this case, because I've got my decimal there, I'm trying to communicate to whoever's reading my lab report that I've got 1, 2, 3, 4 significant figures. You see the difference? This one does not have a decimal, and this one does. Now, numbers in scientific notation. If you're trying to communicate to someone if you're looking at this number, 3, 5, 1, 2, 4, 1, 2, 3, 4, 5. If you're looking at this number and you want to communicate to whoever is, actually if you're looking at this number, if you're trying to communicate to whoever's reading your lab report that this digit is precise and this digit is precise, you've got some kind of instrument that measures precisely these 2 numbers. We have to communicate in our lab report this way, 3.0 times 10 to the 5th. That tells us that both this digit and this digit are significant. Okay, let's look at 503.0500. This 0 is significant because it's between significant non-zero numbers. This 0 is significant for the same reason. These zeros are significant because they're the last digits behind the decimal. So we've got 1, 2, 3, 4, 5, 6, 7 significant figures here. Now let's take a look at 0.000320. Again, I'm going to let scientific notation come to my rescue here. When I write this number in scientific notation, I'm going to write 3.20 times 10 to the negative 1, 2, 3, 4. Now, these zeros are merely placeholders. But this 0 is the last 0 that is following a decimal point. So this one is going to have 3 significant figures.